about two-letter permutations of D, E, F, G. So we can do that calculation from the formula. D, E, F, G, writing them in two-letter strings, D, E, E, D, F, D, G, D, etc. There they are. But how many combinations of two-letter strings are there? And honestly, if we see ED, then, or DE is the same as ED. So we're gonna keep one, cross one. DE, now we're on DF, cross off FD. Next, DG, cross GDF. EF, cross out EG, or EF right there, cross, keep, cross. So 6. There are 12 permutations, but we're gonna keep 6 combinations of two-letter strings. And just to make sure that this works and confirm that this works, we're gonna do it here, 4 choose 2. So 4 choose 2 is the total number of permutations divided by our two-letter strings that we're keeping. So permutations would be 4 factorial over 4 minus 2 factorial, and then all of that's divided by the 2 factorial. But this rewrites nicely like this. 4 factorial on the top, and these 2 on the bottom. 4 minus 2 factorial times 2 factorial. So our calculator work, here we go. Calculator says, it should say 6. We already know what the answer should be. Let's confirm the calculator is giving us the right answer. So first of all, I'm gonna go menu 5-3. That's the combinations code, and I'm gonna go 4, 2, 6. But I'm also gonna do this with the fraction structure to show you that NCR can be trusted because what it's doing is 4 factorial over 4 minus 2, oh come on, parentheses, 4 minus 2 factorial times 2 factorial. Boom, 6. BT dubs. This is where the exponent or the exclamation mark for factorial is located. You click on the little button above P next to G, this area right here, and then a menu pops up where you can select the factorial from the menu. I'm gonna go menu 1-5 and clear this all out. And now we're gonna answer question 4. How many 3-letter permutations of WXY are shown? Well, there they are. WXY, XWY, etc. There they all are. How many combinations of 3-letter strings are there if we have 3 things chosen 3 ways? 3 choose 3. This is the same as that, as the same as that, as the same as that, as the same as that. There is just one. There is one combination of 3-letter strings from 3 things. From 3 elements. Because you chose them all. You chose every single one. And if you choose every single one, then you have just one way of rearranging them. So write a value in factorial notation to make the equation true that 1 is the answer. Remember, it's permutation divided by 3 factorial, the number of elements that we are putting in our group elements. So this is 3 factorial over 3 minus 3 factorial times 3 factorial, and so much cancels out here. These 3 factorials reduce to 1, and then 3 minus 3 is 0, and 0 is factorial because it's in the parentheses. In fact, that's not a reduction. But 0 factorial, there's only one way to arrange nothing, and it's one way of arranging it. So this is really 1 over 1 equals 1. Wow. How did you determine the divisor? The divisor is this complex fraction. Treat this as over 1. Having a complex fraction is challenging, annoying, can be written more simply with the reciprocal. Flipping or writing the reciprocal of the denominator and then multiplying the denominator to the numerator allows us to reduce there. And this is our 2 factorial on the bottom, as that says. Thanks for watching. This has been Combinations. We have more combinations to discuss in the next page, so stick around.